Okay. Anyway, I will put this video, so you can listen that. I will put that small piece. වන්න විතර ඇහුණනේ එක නේද පුතා? Okay, good. And the other thing, is what we have done last week. So last week, we came to understand the four major components and the energy interactions. I think I already shared with you this 1D note. I cannot remember whether I upload this video upload කරවද පුතා last week.
No, sir.
Oh, no. So hope you read this and you have some understand about this energy interactions in flow process. Okay. So whatever here, component, evaporators, condensers, compressors, flashing devices, if you have a single input and single output, and with heat and work interactions, you can write this energy balance. So steady state means whatever system, the stabilization is very important. So once stabilized means it is steady and the flow through the components, you can write the energy balance. So this is from you. The one-time note is a very interesting text. We put this. Okay. Interesting. So if we continue from here, okay, let me continue from here today. I take this slide. And let's say this is evaporate. Okay. Customizing. Evaporator. Flow in, flow out, steady flow. Evaporator means no work done. So I just strike this. So we can say W unit is 0 or no work done. No work done. So no work done. Okay, good. And okay, before that, maybe I will rearrange this. So I need H out. I need H out for this case. Yes. Then I just make it, I put right into left and left into right. So and the next step is I divide this by m dot. I divide this. Let's say yes. So I will rearrange this. In this way. I hope you can understand this. Just rearrange. Okay. Just rearrange this. And the next is with this rearrangement, it's the same, no difference. So we have H out. For evaporate. H in plus this kinetic energy in and out, potential energy in and out, and the heat interaction with the evaporator or this control volume. So we rearrange this way. So you may notice that Z1 and Z2, Z1 minus Z2, this one the value is almost negligible. So I would say 0, almost 0. The same way, velocity is also very small, and the differences are negligible. So this term also negligible. Okay, good. But, and this heat and work interaction here, W term also negligible because no work done unless it's a temperature. So you imagine this entire negligible. This entire potential energy differences negligible. And this W net negligible. So likewise, this will be simplified. I take the negligible terms out. I take the negligible terms out. And then I take the negligible terms out. Yes. And then it's like this. Finally, like this. So this is Q in net by m dot. So I will simplify this again. In this way. So per unit mass, this is Qn. So per kg, so whatever all consider in Q in net, everything Q in. Okay, Q in net. Interesting. And if I rewrite it again, even I take this net out, okay. This is the final expressions. H out is H in plus Q in. In means towards the system. Interesting. If it's condenser, also the same, because for condensers also no work done. That's the point. So H out, H in plus Q in. So let me simplify this. So I take all out. I just put 1 kilogram. 1 kilogram. 1 kg in, 1 kg out. second or whatever. So Q in is this. So no work interactions. So this is Q in. Okay. Z in is a doubt. See now, if you read this the same way, yeah, you have Z in and Z out, C in and all, but finally, this is simplified. Very nice. Okay. So if we take an evaporator coil, this from the web I take. So here, to do some work, there should be a way, but here no work is there. Okay. But sometimes the vibrations and all can be considered as disturbances of work, but here no work. Evaporator coil inside. So let's say this is evaporate coil. Yeah, this is the evaporator coil. You have in, you have out. Freon means earlier used the word, but this for refrigerant. In, out. So see, in here, go out. So this is something like a single tubing, but this is tube with fins. We call fin and tube. So what I need to choose? When steady flow, 1 kg in, sorry, 1 kg out. Okay. So energy in, energy in. So U plus PV means H in the previous ones. So I just put as H in because only significant, overall significance is the enthalpy. The same way, enthalpy is U plus PV. So I will put this H in. Okay. H in plus kinetic potential, or finally H in. Same way, H out, E out, E out. This one. Overall, this is, what significant is this? U plus PV out. U plus PV out is H out. So you should be able to read this. H, internal energy plus the flow work or displacement work. Yeah, E out for 1 kg. Very nice. Okay, good. And cooled air goes out means this receives heat. So I take from here, Q in. So this Q in, when the refrigerant flow through here, let's say for 1 kg, this receives this much Q in. So your energy balance, E in plus Q in is E out. E in is H in plus Q in is H out. So back to this. H in plus Q in is H out means H out is H in plus Q in. Interesting. Okay. Very good. The same way, condenser coil. Normally, condenser coil evaporator can be flow in from down and flow out from top. But condenser, flow in is from top, flow out is from bottom. Practically, that should be the way. So let me try to put that. So I'll take this. Why condenser coil feed in from top and out from bottom? That is technology. That is technology, you know. In and out. Okay. So condenser. So not the warm air, but let's say ambient air. Then in warm air out. So warm air out. For this case, see, ambient air become warmer and out. So the QH real direction is from the coil to outside, but still we can put Q in here. But the point is that this QN sign convention wise, this would be a negative value. Okay. This is a negative value. Small q. How about the previous one? Yeah, Qn. Negative value. Qn, okay. Qn is a negative value. because it is plus. So that will be negative value because in actual case, this is releasing. Now it's the same. Energy in plus Q in is energy out. So energy in is H in plus Q in is energy out is H out. So H in plus Q in is H out. So H out is H in plus Q in. Same. Okay. Very nice. So this how we are analyzing condenser coils and the evaporator coils. So this condenser evaporator coils, but when it comes to industry, let me share. You can see huge coils, evaporator coils. Even in air handling units, you can see these coils are placed. Even in refrigeration systems, this is all become ice blocked, ice buildup we call. This is evaporator coil in air conditioner. So on the wall inside, you may see this. Okay, this is how the compact construction of this. So ends are joined with U-like clips. So all U clips insert into the fins, expand it, and then the other end you add U clips. Have you seen this construction? I have seen in some Japanese factories how they do the coils. So still they are doing, the world is doing in this way, the compact coils. See, so now you have to read this like how you are reading the pen. Okay, you have no thought of reading a pen, but you know how to read a pen now. Not write using a pen, not writing, but the reading. Same condenser coils. Okay, the big ones. So condenser coils, there should be very big ones to even to small ones. Okay, normally placed outdoor or even in our small refrigerators, you can see condenser coil behind or underneath. These are for small appliances. You can see this nature of condenser coils. So quite standard manufacturing. So you may notice this. So let me put a picture of condenser and evaporators. See the fan also there. Let me see the fridge behind condenser coil. These are very low-tech ones nowadays. Very nice schematic. We will take this one also for the presentation. So condenser coil. We will take what? See whether we can have one. Condenser coil. Maybe I will do this way. Condenser coils. So all you can see in and out. So what I will do is I will take a snapshot of all. No harm, eh? So all same, no difference. Single in, single out, or multiple in, out, no much difference. Similar analysis, similar way. So I duplicate this for evaporator coil. Evaporator coils. But I need this image. For your future reference. Evaporator coils. See. So I will take a snapshot of this. Good. Evaporator coils. Yeah. Condenser coil. Like this. Okay. Same energy balance equation. Condenser Q in is negative. That's all. Evaporator coils. Again the same. See. So if I take this for compression, we have 4 minutes. Compression. there is work interaction, and even there could be heat interaction because compression is generally hot, so there can be heat release. So I keep this. So it is like this. So for compression, W net is not zero. So you must have Q in plus W in net, both here. Kinetic energy terms, negligible. Potential energy terms, negligible. Now these two terms, zero. So K win plus W in net. So here for compression, net, not necessary, I just put W in. So compression, just put Q in. Yeah. As long as if you understand, that is good enough. Now we have H out is H in plus Q in plus W in. See, Q in by M dot, W in by M dot. So plus W in. W in. See. This for the compression. So it's 5:30 now. You may have some other lectures, I don't know anyway. Let me stop the class today, and next week, 2 hours, we will complete this system, this analysis as well, and then we will summarize this before going for another section. And we will do some analysis as well. If you can have 5 minutes, I can explain this a little further. But anyway, let me stop the class as it is 5:30. So, hope you understand something. And today I will upload this presentation. So the part of this, the initial part is about reading the pen. So when you see the pen, you should read it. When you see a compressor, you should be able to read it, not the label. Yeah, evaporator, so that technologically you should be able to read these things. Then you can have a very sweet learning and working on the subjects. Okay, Butala. So let me save this, and I encourage you to join the class whenever possible. There may be power cuts, true, but don't avoid the lectures, because avoiding lectures is disadvantageous to you, especially this class. So I'm sharing this subject with my lot of experiences. Yeah. So I'm trying my best to explain this with blend of some practicalities and theory. So you may have some better understanding. But anyway, my contribution is only 75%, sorry, 25%, and yours will be the rest, the 75%. So understanding is totally with you, and you have to have some commitments. Even though you have learned some refrigeration, still a lot for you to learn. Okay. So don't be satisfied with the available knowledge, because that is not sufficient at all. So at least you should know now how to read the systems and the parts or components, or including this ballpoint pen. So many things to go. So encouraging you to join the classes, that is very important, because later following the videos, it won't happen. And the other point is you need the attendance as well, because that is very important. So we can judge that also. So make sure you're joining the class. That is very important. Okay, Putala. So if no questions, so I will update this. I will upload this. I will email this note to you today. Also, I will upload the video to you as well. So keep learning. It's your part of your things, because it's lifelong learning. You have a lot of things to learn, not only technologies, but learning technology helps for all. But you should learn the technology in the way supposed to learn technology. Yeah. Then it will help for all. Yeah. This is not just the so-called studying. Okay. I'm not preferring reading the books. Technology is different. Okay. Thanks, Futala, for joining the class today. So let me wind up the session. So before winding up, if I take the summary today, yes. Today I save this with the previous day slides and the unique knowledge that everyone should aware. We work with the substantial, but the emptiness is what we use. I use the same text. Okay. Because there may be reason why they use substantial instead of substances. Okay, substantial means it's measurable, quantifiable, and it is more material. But the emptiness is what we use. So emptiness has no substantiality. Okay. We work with substantial, but we are using the emptiness. So I've explained this with the pen example. And I talk about reading the pen, not the reading the books. Yeah. So from the previous day slides, I simplify this. For evaporator and then evaporator condenser, it's common. So evaporator condenser further simplified. For evaporator coil, this way. H out is H in plus Q in for 1 kg. Evaporator coils. So whatever, this will apply. This energy balance will apply. Condenser coils, you know that. In from the top and leaving the bottom. Condensers. So same ambient air comes, warm air out. If you consider energy received by the refrigerant or the working fluid, then this receiving is negative because it is really releasing in the condensation process. The refrigerant release it and become liquefied. So we take it as receiving in negative, then we can consider the same what we have developed for the evaporator. Condenser coils. Yeah. You should be able to read this, not just saying many things there. Okay, your power of imagination will boost up when you are reading the things. Yeah. So then we came to the compression. Finally, we have a simplified expression here. So that's all for today. I just put this for maybe later use if necessary. So thank you very much for joining the class, Buddha, today. So hope you understand this. Let me upload the video and today note as well. So bye then. See you next week. Bye.
Thank you very much, sir.
Thank you, sir.
Thank you, sir.
Okay, Bhutana, thank you.